very similar way, we can't cancel out the squareds. If you went through and you did 1 over a squared plus 1 over b squared, this was the correct course of action. You did want to fix the negative, keep it all under the radical. But can I now split this into the root of 1 over a squared plus the root of 1 over b squared? Am I allowed to do that? No, because once again, what is this? A binomial. Can you split a radical through a binomial? No. So if you did this, what you would have ended up with was 1 over a plus 1 over b, and that's wrong. If you did it this way, you would have ended up with 1 over a plus 1 over b, and that's wrong. We cannot split a radical through a plus sign. Can't do it. So if we're not allowed to split a radical through a plus sign, then what should we have done here? Any ideas? Noah?
Combine the fractions.
Yeah, basically add the fraction. How are we going to add the fractions? We must first create a common denominator. And what's our common denominator for a squared b squared? It will be a squared b squared. So in the first fraction, in order to get a denominator of a squared b squared, we have to multiply top and bottom by b squared. And in the second fraction, to get a denominator of a squared b squared, we have to multiply the numerator by a squared. So now I can add underneath this radical, and I'm just going to change the order since addition's commutative and I like alphabetical. So I'm going to write a squared plus b squared over a squared b squared. Now we are not allowed to leave a fraction underneath a radical. So what I'm going to do is I'm going to go from one illegal thing to another illegal thing. What do I mean? I'm going to split this into a radical in the numerator over a radical in the denominator. But in the denominator now, does that square root cancel out the squareds? Absolutely. How come in this scenario it canceled out the squareds, but in the very beginning it didn't cancel out the squareds? How come I'm saying in the denominator it cancels out the squareds, but when it was a plus sign it didn't cancel out the squareds? Michael? Good, because this is multiplication. This is multiplication, so you could treat them separately. So this is an AB over the root of a squared plus b squared. And that is our final answer. Okay, so the second problem was, this is similar to, remember the doozy that we did, that you guys watched, I should say? Right, this is very similar to the doozy. What you want to do is, I'm going to group the first two together. And this is sort of my A plus B. The 3 is the B. And what do we multiply an A plus B by? We're going to multiply it by an A minus B. So my whole A is the root of 30 minus the root of 2. That whole thing I'm considering my A. And then I'm going to change the plus 3. So I'm going to take this whole thing, and I'm going to multiply it by root 30 minus root 2. Remember, your A stays the same, but then we change the sign of the B. So instead of plus 3, I'm now going to write a minus 3. All right, so now whatever I multiply the bottom by, I must multiply the top by. So this is root 30 minus root 2 minus 3. And now I'm going to distribute for that denominator. To multiply that denominator, I'm now going to distribute. So I have root 30 times root 30 is 30. Root 30 times a negative root 2 is a negative root 60. Root 30 times a negative 3 is a negative 3 root 30. Now we go on to the negative root 2. Negative root 2 times 30 is a negative root 60. Negative root 2 times a negative root 2 is a positive 2. Negative root 2 times a negative 3 is a positive 3 root 2. Am I done distributing? No. I now have to distribute that 3. 3 times root 30 is a 3 root 30. 3 times a negative root 2 is a negative 3 root 2. And 3 times a negative 3 is a negative 9. Now I'm going to go to my numerator and I'm going to distribute in the root 2 into my numerator. Root 2 times root 30 is a root 60. Root 2 times a negative root 2 is a negative whole number 2. Root 2 times a negative 3 is a negative 3 root 2. So now I'm going to go to my denominator, and guess what I'm going to tell you to do in the denominator? What do you think I'm going to recommend we do now? Combine like terms. Let's simplify down this denominator. So I'm going to combine my like terms. So in my denominator, I have a positive 30, a positive 2, and a negative 9. So that brings us to 32 minus 9 is 23. Then I have a negative root 60 and then another negative root 60, which is a negative 2 root 60. I have a negative 3 root 30 and a positive 3 root 30. What happens there? They cancel right out. Negative 3 root 30 and a positive 3 root 30 cancels. Then I have a positive 3 root 2 and a negative 3 root 2. What happens there? They cancel right out. In my numerator, I have root 60 minus 2 minus 3 root 2. Before I go to the next phase of this problem, does anybody know what I'm going to recommend we do now? Yeah, right now, root 60, can't that be simplified? Right? I could find pairs in 60. So if we can simplify a radical, you have to simplify that radical. So instead of trying to wait and simplify it at the end, I'm going to simplify it now. So if you have the root of 60, 60 could get broken down into, I don't know, let's say 2 and 30. Then 30 will get broken down into 2 and 15. Is it worth breaking down the 15? No. Why is it not worth breaking down the 15? There's no more pairs to be made. Exactly. So now what we end up getting here is 2 root 15. That's the root 60. So in my numerator, I have a 2 root 15 minus 2 minus 3 root 2. And in my denominator, I'm going to have a 23 minus 4 root 15. At this point, before I go on to the next phase, I would look. Is there a GCF I can pull out in numerator and denominator to sort of make things smaller? No, would have been nice though, right? But unfortunately, there's nothing I can pull out. So now we're going to do the whole process all over again, but it's going to be a little bit better this time. What am I going to multiply this time by? Philip?
23 plus 4 root.
You got it. So we have our a minus b. We multiply by a plus b. So it's going to be 23 plus 4 root 15. And guys, don't you know a minus b times a plus b? Isn't that just a squared minus b squared? Isn't that dots? So do I actually have to FOIL out, or could I just square a and square b? What do you think? Do I actually have to distribute this out, or could I just square A and square B? We could just square A and square B because we know A minus B times an A plus B is an A squared minus B squared. That's a dots. So then this is going to give us 23 times 23, which is 529. And then 4 times 4 is 16. Root 15 times root 15 is 15. All right, in the numerator, do I have to distribute out? Yeah, in the numerator, I have to distribute out. So let's do that. 2 root 15 times 23 is a 46 root 15. 2 root 15 times 4 root 15 gives us an 8 times 15. Negative 2 times 23 is a negative 46. Negative 2 times 4 root 15 is a negative 8 root 15. One more. Negative 3 root 2 times 23 is a negative 69 root 2. Negative 3 root 2 times 4 root 15 is a negative 12 root 30. Okay, so now we're going to simplify this numerator. 46 root 15 plus 8 times 15 is 120, minus 46 minus 8 root 15 minus 69 root 2 minus 12 root 30. And in our denominator, we're going to have 529 minus 240. 529 minus 240 is going to give us 289. Like terms here, so I have 46 root 15 and a negative 8 root 15 is going to give us 38 root 15. I have a positive 120 minus 46 is going to be a positive 74. And then there's no other like term, so it's just minus 69 root 2 minus 12 root 30. Out of all of these radicals, can any of them be simplified? 15 to 30? No. So this is our final answer. All right, moving on to today's lesson. Moving on to, yes, Tejas.
If you have a negative in the denominator, do you have to, like, divide it out?
You don't have to. You could leave it. All right, new lesson. So now we're at this point we've only dealt when with radicals when the index is 2. Now we're going to deal when the index is any other whole number. So let's see. Let's just recap. We know the little check mark thing is our radical. The number underneath our radical is our radicand. And the number by the check is the index. Okay, so let's say I change the index to 8. I mean, sorry, 3. Let's say I change the index to 3. So this reads as the cubed root of 8. This is saying what number times itself 3 times will give us 8. So when we go through our little factor trees, we're no longer looking for twins. We now want triplets. We're looking for groups of 3. Whatever that index is, that tells you how many groups you're looking, how many you want to group together. So the index was 4, that means you want to find groups of 4 of the same number. If the index was 5, that means you want to find 5 of the same number. So when we break down 8, we know 8 is 4 and 2. And then 4 becomes 2 and 2. Do we have our triplet? Yes. So that means anything you circle comes out 1 time. So I circled 1 group of 2s. That means 1 2 is coming out. Is there anything left on the inside? No. This tells us 2 times 2 times 2 is 8. So let's say I have the cubed root of x to the 12th. So again, we're looking for groups of 3. Now, x to the 12th, isn't that 12 x's being multiplied together? So how many groups of 3 can we make if it's 12 x's? 4. Yeah, what did you guys really do? Divided, right? Didn't we divide also when we were taking the square root? Yeah. Whatever the index is, and we're dealing with variables, you go to the exponent, you take the exponent, divide it by the index, and that tells you how many are going to be coming out. So right now, I'm going to take 12 and divide by 3. That gives us 4. So that means x to the 4th is coming out. Is there anything left on the inside? No, nothing left on the inside. All right, let's say I have the cubed root of x to the 5th. Same process. 3 goes into 5 how many times? Just 1 time. So that means 1x will be on the outside. Now, be very careful here because in the past, I've had to take off a decent amount of points when kids forget this. When I come to write my new answer, right, we started with the cubed root. We can't then all of a sudden lose our index. We still need that index of 3. So now 1x came out. How many x's are left on the inside? 2. So x squared is left on the inside. All right, let's put together a number and a variable. So now I'm not doing the cubed root anymore. Now I'm doing the 4th root of 48y to the 6th. I'm going to ignore the y to the 6th for a second, and I'm going to just start breaking down the 48. So for 48, I can do 16 and 3. And then 16 becomes 4 and 4. Can I just circle those 4s? No, because we're looking for groups of 4. So now we're breaking down that 4 into 2 and 2, breaking down that 4 into 2 and 2. Do I have a 4-sum? Yes. So now 1 group of 2 is coming out. So 1, 2 is coming on the outside. What is left on the inside? Tori? A 3. All right, we're not done because we still have that y to the 6th. 4 goes into 6 how many times? 1 time, right? How many y's are left on the inside? 2. Oh, not 6, 2. Is it important that I have that index of 4 written on my final answer? Yes. Okay, you all try this one. The 5th root of 64 x to the 2nd z to the 11th. So now we're looking for groups of what? 5. Yep, looking for groups of 5. All right, who has an answer for me? Danny?
2z squared with the index of 5 root 32x squared z.
32?
Yeah. Oh. Is it like 2?
It is 2. So it's 2x squared z. Where did we get 32 from?
Well, I thought like the 5 2's multiplied at 32, so when I was doing that, I was like, oh, there's 32 left over.
Okay, I see what you're saying. Nope, so that 32 got pulled out because they were a group of 5. What's wrong?
Oh, no.
You're okay?
Yeah.
Does anybody want to see me do this? Are we a little confused? We're okay? James, you're okay? Okay. Is the index of 5 important? Is the index of 5 important? Yes, very important. All right, next one. So this is completely okay. The cubed root of negative 125. How come I wasn't allowed to have the square root of a negative number, but I could have the cubed root of a negative number? Any ideas? So yeah?
Because when you cube something, it's an odd number of negatives, so you can end up with a negative.
Exactly. When we have a square root, that means it's a number times itself. Any real number times itself, even if they're negative, won't the product be positive? Right? Well, in the world of real numbers. Right? But can there be a number times itself 3 times that will be negative? Absolutely. A negative number times itself 3 times will be negative. So in this scenario, what we want to do is we want to immediately pull out the negative. So now I have the cubed root of 125. And we know the cubed root of 125 will be 25 and 5, and then 5 and 5. So here's our triplet. So because I circled one group of 5s, only one 5 is coming out. Is there anything left on the inside? Nothing. Okay, you guys try this one. The cubed root of negative 40. All right, who has an answer for me? Noah. You got it, negative 2 cubed root of 5. Anybody need to see me do it? No. Okay, so now let's go on to adding and subtracting. Now, in order to add and subtract, not only do you need the same radicand, but you also need the same index. if the index is different, you cannot add or subtract them. Oh, sorry, this should be a minus. Minus cubed root of 81. So looking, do all three of these terms have the same index? Yes. Do they have the same radicand? No, but what can I do? Just simplify. So let's break down 24. We can go 4 and 6. 4 becomes 2 and 2. 6 becomes 2 and 3. So now I got my group of 2's. Whatever you circle comes on the outside one time. So I have 1, 2 coming on the outside. What about what's left inside the radical? What number's left inside the radical? 3. And now 81, I can break it down into 9 and 9. 9 becomes 3 and 3. 9 again becomes 3 and 3. I have my triplet. I'm going to pull 1, 3 to the outside of the radical, and we're going to leave 1, 3 inside the radical. Notice I didn't lose my index. I wrote it for all of these. Now that they have the same radicand, now I can add them. 5 cubed root of 3 plus 2 cubed root of 3 is 7 cubed root of 3. Minus 3 cubed root of 3 gives us 4 cubed root of 3. All right, now let's talk about multiplying. All right, in order to multiply, you need the same index. Do you need the same radicand? No, you do not need the same radicand, but if they do not have the same index, you cannot multiply them yet. In a future lesson, I'm going to show you how to do it, but as of right now, we can't. Okay, so let's say I have the 4th root of a d to the 3rd times the 4th root of 10d times the 4th root of d to the 2nd. Okay, they all have the same index of 4, so you have options. What you can do is, if you were able to, you can try to simplify first and then multiply, or you can multiply and then try to simplify. It really does not matter. So here I'm going to multiply. So I have the 4th root. 8 times 10 is 80. Now multiply the variables. D to the 3rd times d to the 1st is d to the 4th. D to the 4th times d to the 2nd is d to the 6th. And now I simplify. So if we have 80, I can go 10 and 8. I know 8 is 4 and 2. 4 is 2 and 2. Is it worth me breaking down the 10? Is it worth me breaking down the 10? Yeah, why? Why is it worth me breaking down the 10? Michael? I could get another 2 to make a group of 4. So then here's our group of 4. I'm going to pull out 1, 2 to the outside of the radical. And a 5 is left inside the radical. And for variables, it's pretty simple. 4 goes into 6 just one time, so that means just one d is coming out of the radical. How many d's are left on the inside? D squared, you got it. Okay, let's talk about dividing or quotients. Yes. How do I simplify what?
How do you simplify it first and then multiply? Because you said there are 2.
Well, in this one it wouldn't work because there's not 4 of anything, but sometimes there will be 4, so then you could have simplified first and then multiplied and then looked to simplify again.
So then, like, if the 8 was 16,
Mm-hmm.
and you pulled out the 2,
Yep.
do you just leave the 2 in the answer? Like, outside of that?
Well, that, and yes, then you would multiply the 2 times whatever coefficients were here. In this scenario, it was just 1, so yeah.
So the final answer would be like 2d 4 is the inverse of 5 squared. That's it.
So I'll write it out for you. So if we had 4, the 4th root of 16d to the 3rd times the 4th root of 10d times the 4th root of d squared, you wanted to simplify first, right? This would have been 2 times the 4th root of d to the 3rd times the 4th root of 10d times the 4th root of d squared. So then you multiply, and you're going to get 2 times the 4th root of 10d 3, 5, 6, d to the 6th. And then you'd still have to simplify the d to the 6th, right? So then this would be 2d times the 4th root of 10d squared. You're welcome. Okay, let's say I have the cubed root of 2 a to the 4th over 27 a to the 6th y to the 15th. Sorry, make this a to the 3rd. There we go. 2a to the 3rd over 27a to the 6th y to the 15th. So if we wanted to, can we simplify underneath this fraction? Absolutely, we can simplify underneath this inside the radical within the fraction. Really, the only thing I can divide is a to the 3rd and a to the 6th, right? What's a to the 3rd divided by a to the 6th? A to the 3rd where? Bottom or top? Bottom, because there's more a's on the bottom, right? So this is going to be the cubed root of 2 over 27 a to the 3rd y to the 15th. Are we allowed to have a fraction underneath a radical? No. So we're going to go from one illegal thing to another. I'm going to split it into the cubed root of 2 over the cubed root of 27 a to the 3rd y to the 15th. Good news is I can simplify this denominator. 27, isn't it 3 times 3 times 3? So then 1 3 is coming out. The cubed root of a to the 3rd is just a. What's the cubed root of y to the 15th? Y to the 5th. No more radical in that denominator. And in my numerator, I have the cubed root of 2, which I have nothing I can do with it, and that's perfectly fine. This is our answer. what's wrong with this problem, or what's the problem with this? There's something that's really bad about it. What's really bad about this? Ideas? That we're not allowed to have. Tori? Yeah, there's a radical in the denominator. When it was the square root, when it was just the square, let's say I had, don't write this down because it's not the problem, but if I had the square root of, 1 over the square root of x, how did I fix this? How did I rationalize it? How did I get rid of the radical in the denominator? What did I do? Philip?
Sorry, no, wait, no, I forgot what we did, my bad.
You're on the right track, James.
So you just multiply by x.
Yeah, you just multiply it by itself. So wouldn't we just do root of x bottom, root of x top, and that would give us root of x over x? Let's say we tried that here. So I'm like, okay, well, I can't have a radical in the denominator. I'm just going to multiply it by itself. So I'm going to multiply by the cubed root of x squared times the cubed root of x squared. Well, in my denominator, x squared times x squared is x to the 4th. But then isn't that 1, 2, 3, 4 x's? So 1 x would come out, but wouldn't there still be an x on the inside of that radical? So did that fix the radical being in the denominator, multiplying it by itself? No. So rationalizing, multiplying it just by itself only works when it's an index of 2. This does not work for any other index. So what do we have to do? Well, I need, in order to get rid of the radical, don't I need 3 of the same thing? In order to get rid of the radical, for this radical, I need 3 of the same thing. Don't I already have 2 x's under here? X times x? So what does that mean I have to multiply by? Just 1 more x. So this is going to be the cubed root of x times the cubed root of x. So in my denominator, I'm going to have the cubed root of x cubed, and in my numerator, I have the cubed root of just x.
Wait, how'd you get only the x in the index?
I chose it. The reason I chose it is because right now, in order to simplify and have no more radical, because the index is 3, that means I need 3 of the same. I already have an x and an x times x. So I would need just 1 more x to make a group of 3. So that's what I decided to multiply by. And remember, in order to multiply, they have to have the same index, right? I can't multiply an index of 3 by an index of 2. It doesn't work. They need to have the same index to multiply. So that's how I knew it had to be the cubed root of x. So now what's the cubed root of x cubed? Just x. And in my numerator, we have the cubed root of x. All right, let's try another one. Okay, so I'm going to go from, I can actually simplify the 2 and the 36 to 1 and 18, but actually I'm going to choose not to, and you're going to understand why in 1 minute. I'm not going to simplify the 2 and the 36. I'm going to split this into the 4th root of 2 over the 4th root of 36x squared. Okay, now what I'm about to tell you is really important so you're not dealing with astronomical numbers when it comes to the test. What I'm about to tell you is very important so you're not dealing with astronomical numbers when it comes to the test. Right now, I know I have an index of 4. So in order to cancel this radical, I would need 4 of the same, right? I would need groups of 4. Now, you can say, well, I have 136, so I'm going to multiply by 3 more 36s. Or you could recognize that 36 is 6 and 6, right? There's a pair there already. So instead of making this 3 more 36s, I can look at this as the fourth root of 6 times 6 times x times x. Right. And so why does this change things? It essentially just makes my life a little bit easier, so I'm not dealing with as big of numbers. So now I need 4 of the same. So instead of multiplying by 3 more 36s, I already have 2 6s. So I could just multiply by 2 more 6s. Isn't that a lot nicer to work with than 3 36s? So I have 2 6s and I have 2 x's. So in order to cancel out this radical, I'm going to multiply by 2 more 6s and 2 more x's. So multiply the top and bottom by this. So in my denominator, I'm going to have a group of 4 6s, so 1 6 comes out. I'm going to have a group of 4 x's, so 1 x comes out. And in my numerator, I'm going to have the fourth root of 36x squared times 2, which is 72x squared. If I break down 72, will I get 4 of any number? No. If we break down 72, we will not get 4 of any number. So this is our answer. Noah?
In the beginning, if you turned the fourth root of 36x squared into a square root of like 6x, is that also acceptable?
I know what you're doing. We're not quite there yet. We're going to be there, but yeah, I'll explain that in a future lesson, but it will be you will be able to do it for a test. All right, you all try this one. Who has an answer for me? Who has an answer? Nobody? Somebody does. Michael?
431 should be 5 over 5A.
That's correct. How many people got that? Why does nobody want to give me their answer? All right, guys, there's one thing I haven't showed you, which I'll have to show you next class. But overall, you will be able to do your homework all except number 57.